We are going to start by marking the point that we want to estimate the instantaneous rate of change. So we're estimating at t equals 2. So we come up here, t equals 2, go up to the graph, that's right there. Do I have a volunteer who will be on video to come and try and draw the tangent line? Go, James, thank you.
Seems like a fun thing to do. Yeah, let's do this.
Ruler.
I like blue, yeah.
Okay, so before you start drawing, just put the ruler where you think it would be. So we want the ruler to touch the graph at one point, and as best as we possibly can, represent the steepness of the graph at that point. James is going about there. What do other people think?
Go further towards the bottom, steeper.
Yep. I reckon that's not bad, James. Draw that on there for me. Bit longer.
Bit longer.
Yep. Beautiful. Thank you very much. Take the ruler away.
Oh, you're welcome.
Okay, so now we've got our tangent line drawn on there. We have to select 2 points on our tangent line to find the gradient for. We've already got 1 point. This point is where t equals 2 and the position equals 10. Which would be the second point that you would select on the graph to help you? 2.5 and 6. Now, I would say 2.5 and 6 is there. We're not quite on that line.
I would say
3.5 and 0. So, Alice, you've gone right to the end there. Okay. 3.5. Oh, I'm going to run out of paper. 0. Now, you can select any 2 points. Remember, when we find the gradient, it doesn't matter which 2 points I use, as long as I select 2 points on the graph. You want to be as accurate as possible when you use the grid to estimate what those points are. So now I'm going to find the gradient. The gradient, y2 minus y1, x2 minus x1. So let's say this is my first point, second point. So y2 is 0, y1 is 10. x2 is 3.5, x1 is 2. So we get minus 10 divided by 1.5, which is equal to what? I'm going to use my fraction skills here. I'm going to do 100 over 15 because I don't like decimals in fractions. And then 5 goes into both of them, goes in there 20 times, goes in there 3 times. And I know that 20 divided by 3 is 6.66666667. And that's a minus. All right. This number. So what I've just calculated is my estimate for the instantaneous rate of change. So that's an estimation. Negative 6.6. So I remember I can use my curly brackets for an approximation rather than straight line brackets. And this was meters per second because the units for the y value was meters per second. The units for the x value was seconds. So that's where this comes from. And if you're good at physics or have done a bit of physics, you might know that this is meters per second squared and that this is equal to acceleration, but that's not what we're focused on at the moment. Okay, so 2 methods. 1, we find 2 points really close together, find the gradient between those 2 points. Method number 2 for estimating, we draw a tangent line and find the gradient of that tangent line. Your time to practice.